A very good morning to all. This one today we are going to see about current electricity in third session. In this sessions we are going to see about the resistors which are connected in series and parallel combinations. In both the NEET, EamCet and including JEE mains, you can expect such type of one questions with some complicated structure with some logical connections and some logics in resistors connection in series and parallel circuit. We can simplify the equations, simplify the circuit so that we can easily solve these equations. Now we are going to see about series and parallel circuit. Now first question one first question here is: a wire of resistance R is cut into four equal parts. See here, one wire which has been cut into four equal parts now, and they are bundled together. Now they have arranged like this. All these wires are bundled together side by side to form a, see, once they are arranging over here, they are going to increase the thickness of the wire and the resistance of the bundle. Now in this case, what are the things is going to happen here is, already we know this formula: R is proportional to L by A, R is equal to rho L by A. In this case, L is going to change, at the same time area is going to increase. L is decreasing, A is increasing, so that what happened here is resistance is not going to change, but in this case resistance, how much the total bundle, if you are going to arrange this one, what is the total resistance of this one, that one we are going to see from this one. First one, R is proportional to L. In this case, if the wires are cut into T4 equal parts, the resistance of each piece, that is 1 by 4th of the original resistance. So here is R dash, that is about one wire which is having the resistance I just mentioned here, R dash equal to R by 4, and all are arranged side by side, which means all are connected in parallel. So this is the formula here. Parallel connection here is 1 by Rp equal to 1 by R dash plus R dash plus R dash. For this one, if you take R dash is the common one, see here, R dash, I just take an LCM for this one, 1 plus 1 plus 1 plus 1. So what you are having here is 4 by R dash. So this one we are going to have, see, that one will be equal to 1 by Rp. So from here, 1 by Rp here is, this is value, so Rp is equal to R dash divided by 4. So that's what you are going to have. Already we found the value, R dash here is R by 4. So R dash value you just mentioned here, R by 4 whole divided by C here. In this case, R dash value here is R by 4. Again you are having 4. So what you are having here is R divided by 16. So the answer in this case, okay. Next one. Question number 2. See here, a wire of resistance they have given. See, a wire resistance here is 18 ohm, is bent into form a equilateral triangle. Equilateral triangle, in this case all the sides are equal, so it has been equally resistance will be if the resistance here is 18, means all the side equally make into a rectangle, or sorry, make into an equilateral triangle. In this case, R divided by 3, already we are having 18, and 18 divided by 3 you are having 6 ohm. 6 ohm is the resistance of each side. This one, see, once you are going to arrange, you just simplify this one. So what they are asking in this case, the resistance of any two vertices, in this case two corner, any two corner, if you consider this one, so they are going to consider between this corner and this corner. So A and B, in this case these two are connected in series, so series connection you can add directly here, and these and this whole setup, that is 12 ohm and 6 ohm, which are connected in parallel in this case. So I just mentioned here both are connected in parallel. So I just mentioned here equivalent resistance which are connected in parallel circuit. I just mentioned here 1 by 12 plus 1 by 6 here. You just take an LCM for this one, 12. So what you are going to have here is 1 plus 2 here, so that is 3 divided by 12. So that one I just mentioned here 1 by 4, that is about 1 by Rp. So from here, resistance which are connected in parallel circuit here is 4 ohm. So the answer here is 4 ohm. Next one. Four conductors of resistance, the same one, see here, 16 ohm, each are connected to form a square. So here is, they are mentioned as square. See, this is not a rectangle. See here, this is a square. They have mentioned this one. All the sides are equal. So 16 ohm and they have given 16 ohm which are arranged on the square. The equivalent resistance across the two adjacent corner. Two adjacent you can mention B, A, B or B, C or C, D. Any one you can take over here. They have given here in this case here is A and D. See, for this one I just mentioned here A and D. In this case I just mentioned here this one is A, and which has been connected over here. This resistance I just mentioned. See, for A and B, one is you are going to have that one here is 16 ohm, and this one, these three you are going to see this one and this one and this one. These three are connected in series. Series means R1 plus R2 plus R3. All you are going to add together. So what you are having here is 48 ohm. This 48 ohm and 16 ohm are connected in parallel. Similar like a large problem, you are going to see this one. So parallel connection here is 1 by R1 plus 1 by R2 here. R2 value here is 16. The same, you just take a LCM over here. 1 plus this is 3. So what you are having here is 4 divided by 48. So from this one you just mention here. So that is 1 divided by 12. So that is about 1 by Rp here. And this one, from this one, Rp is equal to 12 ohm. This is the answer here. Okay, now this one, see in this case how we are getting this formula, both are same, but here is see 1 by Rp, I just simply mention here 1 by R1 plus 1 by R2. See, from this one you can mention here 1 by R2 here. So from this one you can mention here R1 R2 into R1 plus R2. So this one from here, this is Rp here. So from this one, how you are getting here is, I just mentioned here, from this one, inverse of Rp here is Rp is equal to R1 R2 divided by R1 plus R2. So in this one, you just substitute R1 here is 48, R2 here is 16, you just substitute here, even you can get the same one. The next question here is, a 4 ohm resistance wire is bent through 180-degree at its midpoint. See, I just mentioned here, suppose a wire which is having a resistance of 4 ohm at the midpoint, it makes into two halves and they are twisted together. Then the resistance is, what is the resistance of the twisted one? See, I just mentioned in this case, see this one 180-degree in this case. First this one will be moving along this direction. See, I just mentioned here. Then next one which has been bended at the midpoint. See, from your midpoint you are going to bend this one. See here, this direction. See the total one bundle together, what is the resistance of this bundle? That's what they are asking here. For already you know this one, the resistance of the wire. See, I just mentioned here R is proportional to L divided by A, or even R is equal to, from this one, R is equal to rho L divided by A. So this is about the formula here for this case. Once you are going to bend this one, the resistivity of the material is not going to change. Only thing is length, the area is going to change here. So what is the changes in the length here is, once you are making it to two equal half at the midpoint, it's going to change. The length here is L by 2, and both are bundled together. The area will become twice the amount, that is 2A. For this case, see here, already I told rho is not going to change. Only change here is length and area. So R dash is equal to rho L dash divided by A dash, and L value already you know this one, L by 2 for the twisted breaked one at the midpoint, and area of cross section, that is twice the amount I just mentioned in this case. So for this one, R dash is equal to, I just mentioned here, R dash is equal to rho into L here is L by 2 and area here is 2A. So I just mentioned in this case rho L divided by, already 2A you are having, and this 2 will come at the denominator. So what you are having here is rho L divided by 4A. Already you know this one, rho L by A, already you know this value. So for this one, R dash is equal to, see I just mentioned here, R dash is here is R divided by 4. Already they have given R value here is 4 ohm resistance, divided by 4, what you are having here is 1 ohm resistance. So answer here is 1 ohm. Okay. The next problem here is, when two resistors are connected in parallel, then the equivalent resistance they have given 6 by 5 ohm. When one of the resistance is removed, the remaining resistance value here is 2 ohm. That's what they have given. One resistance has been removed means only one resistance is there. That value here is 2 ohm. So the resistance of the wire removed will be the removed wire resistance. That's what they are asking here. See, in this case I just mentioned here For this one, the equivalent resistance I just mentioned here, that is the RP value here is 6 by 5 ohm. Already you know this formula here. See, I just mentioned here 1 by RP is equal to 1 by R1 plus 1 by R2. So this is the formula for the resistance which are connected in parallel. See, this one I just mentioned here for 1 by RP here is R1 plus R2 and divided by R1 R2. So this is the formula from this one again. So RP, so I just mentioned in this case, so this one here is RP is equal to, so here is R1 R2 divided by R1 plus R2. Now in this case, RP value what they have given here is 6 by 5. I just mentioned here 6 by 5 is equal to R1 first resistance. We are not sure about this one. This one R1 I just mentioned here R1, and the second resistance here is 2 divided by R1 plus 2 here. Now cross multiply this. So cross multiply this one. This is 6 R1 plus 12 will be equal to 10 R1 here. Now this is 6 and this one is 10. So what you are having here is 12 is equal to 4 R1 here. So this one R1 will be equal to 3 ohm. So one is about 3 ohm, and another one in the shortcut methods how we can mention here is, see this one in this case 1 by RP, or even you can check it over here how you are getting that answer. See 1 by RP, two resistors are connected in parallel. One they are given, that is 1 by 2. Another one we just assume you just need to substitute this value. If you are getting confused with this one, you just substitute all the values here. So instead of going to this one, you just go through on these two values I just mentioned here in this case. See 1 divided by 3, what you are going to have here is, I just mentioned here this is 6 and this is one is 3 plus 2. See I just mentioned here 3 plus 2. So what you are having here is 5 by 6. So from this one RP is equal to 6 by 5 ohm. So this is the answer already they have given in this case. So this one already they have given in this case. In this way also you can, so in this way you can check it that answer. The next question here is, a technician has only two resistance coil. Now there are two resistance here. This is about the coil similar like this. There are two coils similar this one. Two resistance coil, but they are not sure about the resistance of these two coil. By using them singly in, see here, by using these two only in connected in series or connected in parallel, he is able to obtain a resistance of these four values only. This resistance of two coils, what are the two coils, maybe what are the resistance of these two coils, how you can mention here. See simple this one. In this case you just go to the options, you just add together these two resistance. If these are connected in series, you just add together. This one is 16, add together 10 plus 6 here is 16. So 16 option is there, so this one will be that answer one chance. And this one you just add together 12 plus 14 also 16, so 16 is also available there. So this one also you can consider. Similar like this, 9 plus 7 16 will come, but in this case 16 plus 4 20 will be there, so this options won't be there. So all these three connected in series, you can get this answer. Now next one, if these are all connected in these two coils, so if you consider one is 6 and another one is 4, if these two are connected in parallel, in this case, see here, this is about the circuit which are connected in parallel. 1 by RP is equal to 1 by R1 plus 1 by R2, or even RP equal to R1 R2 divided by R1 plus R2. In this way, for the first case, listen here, R1 here is 6 and R2 here is 10. Now you just mention in this case 6 into 10 divided by 6 plus 10, what you are getting that answer here is 3.5. 3.5 it's not there, only 3 is there, so this options won't be there. Next one, see here, in this case one is 4, one is 4, another one is 12. 4 into 12 divided by 4 plus 12, you are getting that answer here is 3. So 3 is available over here, so you are having 3 here, so this also chances are there. Next one we'll see here again. See this one 7 into 9, if you put 7 into 9, that answer here is approximately 3.93. so 3.93 is not there, so this answer won't be there. In this case this answer won't be there. The fourth one you just try here, this one also is not there, so the final answer here is the second one. In this way you can get the answer. Next question here is, if three wires of equivalent resistance, see here they have given three wires of equivalent resistance are given, then the number of combinations, see here, you can see this one, combination and permutations in case of mathematics. That's also a similar concept here. And this one, the number of combinations by then can be made to give a different resistances. Say for example, in this case, now if you have given a three resistance of equal one resistance, or if three resistance, one chances here is all can be arranged in series. So this one here is R1 plus R2 plus R3. All are equal in resistance. R1 plus R2 plus R3 here is, you can mention here, this one has R plus C equivalent resistance here is R plus R plus R. So what you are having here is 3R. So this one, what you are getting, that answer here is if three resistors are connected in this way. Now, if these three resistors are connected in parallel in this one, R1 and R2 and R3, if these are arranged in parallel in this case, see I just mentioned here, this one I just mentioned in this case, 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R. So this one I just mentioned here. So 1 by R1 plus 1 by R2 plus 1 by R3 here. So I just mentioned in this case R equal to 1 plus 1 plus 1. So what you are having, the resultant resistance here is R divided by 3. So they have given in this case R by 3. Now third case, in this case, if two resistors are R2 and R3 are connected in parallel, see here I just mentioned in this case, if two resistors are connected in parallel and this combinations are connected in series with the first resistor, this one, in this case what is the equivalent resistance? See I just mentioned here, in this case, if R1 and R2 and R3 are connected in parallel, in this case I just mentioned here 1 by R plus 1 by R. So that is about 1 by Rp here. So this one, what you are having here is 2 by R, that is about 1 by Rp. So in this case I just mentioned here Rp is equal to R divided by 2. So this is about the resultant resistance of this combination. So this one and this combinations are connected in series with the first one I just mentioned here. So the resultant equivalent resistance I just mentioned here, that one is R1 here is R plus R2 and R3 combination here is R by 2. So what you are having here is 3R by 2. So for this one, equivalent resistance R here is 3R by 2. Actually what you are going to have, this is not an answer here, see 3R by 2. Okay, now next one, the fourth combination I just mentioned here. See, these two resistors are connected in series. These combinations are connected in parallel. Series connection I just mentioned here, that is about 2R here, and this is connected in parallel. So I just mentioned here 1 by 2R plus 1 by R. That one will be equal to, I just mentioned here, 1 by Rp here. So this one from here I just take a 2R is the LCM, so that I just mentioned this one 1 plus 2, that will be equal to 1 by Rp here. So what you are going to have here is 3 by 2R. So 3 by 2R will be equal to, so what you are having here is 1 by Rp. So this one I just mentioned here. So from here Rp is equal to, what you are having here is 2R divided by 3. So totally how many combinations you are going to have here is this one, first, second and three, total four combinations are there. Next question here is the effective resistance between A and B in the given circuit test. See, like this type of questions you can expect frequently. Now in this one, before going to that, see here, and this one, see 2 ohm and this 2 ohm and this 2 ohm. All these three are connected in series. Now series in this case, you can mention this one 2 ohm plus 2 ohm plus 2 ohm. What you are having here is the total combination of this one I just mentioned here. This one here is 6 ohm. Okay, now this 6 ohm are in parallel with the 3 ohm, and this is about the formula here. Parallel combination of the two resistors here is R1 R2 divided by R1 plus R2. In this case I just mentioned here. So the equivalent resistance here is one is about 6, another one is about 3 here. So this one you have to multiply here, 6 into 3 divided by 6 plus 3. What you are going to have here is 18 divided by 9 here. So equivalent resistance in this case here is 2 ohm. So for this one, for this two combination I just mentioned here, for this two combination I just going to have 2 ohm here, and again the same in this case, this 2 ohm and this one, this 2 ohm and this 2 ohm, all these three are connected in series. So similar concept like this. So the total combination of this one I just mentioned here, this one here is 6 ohm here, this 6 ohm and this 3 ohm are connected in parallel. For this one again I just mentioned here, this one will become 2 ohm again here. See, I just mentioned here, this is 2 ohm, this 2 ohm, this 2 ohm and this 2 ohm, all these three are connected in series. So I just mentioned here, the equivalent resistance across A and B here is 2 ohm plus 2 ohm plus 2 ohm. What you are going to have here is 6 ohm. That is about the answer in this case. See, such type of questions you can expect. See, like a complicated structure but a simple logical oriented here, you can easily solve such type of question. So answer in this case here is 6 ohm. The next question here is the effective resistance between A and B in the given circuit. So they have given the circuit in this case. What is the total effective resistance across A and B? This one we are going to find out, and I just going to give you a short hint, a small hint for this case. You can remember this one. Hope so that you can easily understand. I just tell you a small hint over here so you can understand over in this case. The first one I just mentioned in this one. See, for example, effective resistance between, I just maximize the structure over here. Effective resistance between A and B over here. This one we are going to find out. For this case, first we just consider this structure I just mentioned here along this structure only. Now for this one I just mentioned here. See, this 3 ohm and this 3 ohm are connected in series. So connected in series here is 3 ohm plus 3 ohm. The equivalent resistance I just mentioned here. Equivalent resistance here is these two combined together. This one and this one combined together. What you are going to have here is 6 ohm. And this 6 ohm and this 6 ohm are connected in parallel. Now in this one I just tell you how I can mention this one. These two are in series, and how come this combination are in parallel with this one? A small doubt you may have this one. Hope you remember in case of Kirchhoff's circuit law, Kirchhoff law, and that one also an important 8 mark question in case of current electricity. Hope you remember this one. See, in this case, Kirchhoff's circuit law in this junction. Suppose if you are mentioning about this junction, the current entering towards the junction will be equal to the current exiting junction. Or even in another case, you can mention here, if the resistors are connected in series, current in the circuit will be the same, potentials are differ. Say for example, these two are what I have mentioned here is current will be the same. Say for example, if I current is moving towards here, for example I just mentioned it for the better understanding, even in this resistor also current going here is I only. So these two cases, these two are connected in series, so the equivalent resistance I just mentioned here, this is 6 ohm. Okay, now for this one, this combination I just mentioned here, this is about 6 ohm resistors between this one and another. In this case, these 6 ohm and this 6 ohms are connected in parallel. That's what I told. This one I just mentioned again here. These two resistors are connected in parallel according to the Kirchhoff law, or even a parallel circuit. In this case, parallel circuit, current are differ, voltage are same. Hope you remember in the previous section we have mentioned in this one. See here, for example, in this junction, I just mentioned here, I current is moving towards this junction. From this one, the current will be moving here. This is I1, and this case, this is I2. See, this one here is I current, but here is I2 current. So current is differ in this case. This one you can mention here. These two resistors are connected in parallel. This is one of the hint you can remember this one. See here, current is differ in case of parallel. See, in this junction you can mention here. See, for even in this junction you can mention here, this is I2 current, and this is exiting current, this is I, and this is one is I2. So these two are connected in parallel. This is one hint. And another one, you just remember, if two resistors are connected in parallel, say for example R is about the resistance here, and if they are connected in parallel, in this case the resultant or equivalent resistance here is R by 2. Suppose 6 and 6 are the equivalent resistance. This is 6 ohm and this one also 6 ohm. Both are connected in parallel. So the equivalent resistance of this two combination I just mentioned here, the equivalent resistance here is 6 by 2. So the total answer here is 6 by 2. What you are getting here is 3 ohm. Hope you remember this one. For example, I just mentioned here, 1 by Rp is equal to 1 by 6 plus 1 by 6. So what you are going to have here is 2 divided by 6, that is 1 by 3, that is 1 by Rp. For this one, Rp is equal to 3 ohm. This is the combinations over here. The same concept, hope you remember this one. Suppose if you are having 4 ohm and 4 ohm is there, what is the equivalent resistance? equivalent resistance in this case 4 ohm to 4 ohm are connected in parallel. The equivalent resistance here is 2 ohm. Suppose 3 ohm are connected in parallel. The equivalent resistance here is 1.5 ohm. This is also one of the thing. Instead of putting this one, you can directly mention here. If remember this one, if two resistance are equal, so the equivalent resistance here is half of the resistance. That's all. That is the thing. Now this one here is, see here I just mentioned here, this is 3 ohm and this 3 ohm, both are connected in series. Now according to this one, see here, suppose if the current flowing here is, I just mentioned as capital I. For this junction you just mentioned here already, this is simplified one. Now it has become I here. This 3 ohm and this 3 ohm combined together, what you are having here is 6 ohm, and this 6 ohm and this one, hope you remember this one, this 6 ohm I just mentioned here, these two are connected in this one, these two are connected in parallel. So what you are going to have here is the equivalent resistance. In this case this is 3 ohm and this 3 ohm and this 3 ohm are connected in series. Equivalent resistance here is 6 ohm. Now so here in this case these combined together, what I am mentioning here is 6 ohm, this 6 ohm and here also this is 6 ohm. Combined together, what you are going to have here is the equivalent resistance here is 3 ohm. And see here, I just mention again here, see this 3 ohm, this 3 ohm and this 3 ohm are connected in series. What you are going to have here is 6 ohm. And now I just mentioned in this case this 6 ohm and this 3 ohm. Remember here, this 6 and this 3 ohms are connected in parallel. In this case what I'm going to have here is connected in parallel. See, both are not a same one. So in this case I just mentioned here 1 by rp is equal to 1 by 6 plus this one here is 1 by 3. Now you just take an LCM 6 here, 1 plus 2. So what you're going to have here is 3 by 6, that is 1 by 2 what you're going to have. So from here rp is equal to 2 ohm. That is about the equivalent resistance across A and B. Here is, what is that answer here? That is 2 ohm. The next question here is the effective resistance between A and B. See, effective resistance between A and B in the given circuit is, that's what they are asking in this one. See, like this complicated structure, you just have to remodify the structure. Once you remodify this one, you can easily understand. I just draw the structure and you can analyze the remodified structure and to the original structure I just draw here. According to this, you can easily understand here. Say for example, I just mentioned here, this is about A resistance. See this one I just mentioned here, from A to B you are having, there are two resistance I just mentioned here. This is A and B. There are two resistance, one is 3 ohm, another one is 8 ohm. See, I just mentioned in this case one is 3 and another one is 8 ohm. See here, this one 3 and 8 ohm, which has been, see in this way I just mentioned here, in this way, which are going to connect, these two resistors are connected in series in between A and B. And this one, see this junction, you just remember here, in between A and the junction you are having 6 ohm resistance. See, I just mentioned in this case, see A and between the junctions of A and B you are having 6 ohm resistance. Hope you remember. Okay, now so this one also we have covered and these two also we have covered. And another one, A to B you are having one more resistor, that is the junctions between A and B I just mentioned in this case. See, in between A and B you are having one more resistor I just mentioned here, that is 30 ohm. Now you can understand here, in between this remodified structure from this original one, even you can cross verify this, in between A and B 3 ohm and 8 ohm, in between A and the junctions between A and B you are having 6 ohm, and between A and B another one more thing, that is 30 ohm. You can confirm over here. Now you can easily modify it with this one, you can easily understand here. See, this 6 ohm and 3 ohm are connected in parallel connection, so that you just remodify this one. This one here is I just mentioned here, for example rp is equal to r1 r2 divided by r1 plus r2, 6 into 3 divided by 6 plus 3 here is 9. So what you are going to have here is 18 divided by, so this one I just mentioned here, 18 divided by 9. So what you are going to have here is 2 ohm. Now the total combination here is 2 ohm. So this 2 ohm and 8 ohm are connected in series. So what you are going to have, I just mentioned here, both are connected in series. 2 plus 8, what you are going to have here is 10 ohm resistance. Now again, This, see, this one and this one combined together, what you are going to have here is 10 ohm. This 10 ohm and this 30 ohm are connected in parallel again. That is about the equivalent resistance between A and B I just mentioned here. That is about, see here, 30 into 10 divided by 30 plus 10 I just mentioned as 40 here. So from this one I just mentioned in this case. So from here is, see, from this one I just cancel it here. So 30 divided by 4, that is 15 by 2 or even 7.5 ohm. That is about the equivalent resistance between A and B. Okay, now see, from this one you can have a practice over like this one. Similar concept, only thing is I have changed only that value, and even this one they have asked in NEET examinations in last year. I'm not sure about in last year, last 1 or 2 years. This questions has been asked frequently. In this case, you just practice here the similar concept what I have done, so that you can easily understand here. Remaining problems regarding similar like this structure will be continued in the next section. You just go through on this one. See, even what are the questions has been covered, that has been given over here.